All right, guys, we are going to go over your spring worksheet that was due on Friday. I know a couple of y'all had some questions, so we're just going to go ahead and dive right in, all right? Okay, let's take a look at number 1. So these questions will be on your test. There's not a whole lot of them, but you do need to be familiar with them. And they're easier than you think, so please do not panic. A spring was at its resting position where it attached to a wall at its left side and a block to its right side as shown below. So there's a picture for you right there. The spring constant is K equals 55 newtons per meters. The block is moved rightwards, and the spring's right end is displaced from the position of 0.1 to 0.25 where it is held in place. All positions measured from origin of the wall. Okay, and we want to find the spring force exerted on the block. All right, so our spring force formula, so what we are going to try to end up with, okay, spring force is equal to negative K times X. Okay, so what that means is that it's going to be our spring constant, our negative spring constant, times our displacement, okay? So remember displacement, we've talked about displacement for a long time, it's just a change in position. So how would we find a change of position? If I start here at 0 and I walk 40 feet, how much is my displacement? Well, we would do 40 minus 0, right, to figure out how far I've traveled. We do the exact same thing with the spring. It's given us all the information that we need. It says that the spring started out at 0.1 meters, and then it stretched to 0.25 meters where it's held in place. So all we have to do is, in order to find displacement, it's going to be our final position minus our initial position. So in this case, we're just dealing with springs. So it's going to be, I have it written right here. Hold on, let me pull up my camera. I have several windows open simultaneously. So we go from 0.1 to 0.25. That's where our spring is getting stretched. So our final position of our spring is going to be 0.25, while the initial is going to be 0.1. That's where it started off with. So we're subtracting where we ended up minus where we started out. And it's going to be equal to 0.15 meters. Figured out how the change of position has happened with our spring. Now we need to figure out our spring force. And then we go back into our formula for that. So our formula is negative K times X. Thank you. Negative K times X in order to find our spring force. So what is our X? Well, we just found that. That's going to be 0.15. All right, and what is our K? K is standing for our spring constant in this problem. So look at the back of the problem, what is our spring constant equal to? It's equal to 55. So it will be negative 55 times 0.15. And you will get, as your final answer, negative 8.25 newtons. Okay? All right, so the next one we do exactly the same way. So we take the displacement, but make sure that you look carefully at this one because the displacement on this one is going to equal a negative number. Why? How do we know that? Because the spring, the position of the spring starts off as 0.25 and then it goes to 0.2 where it is held in place. So it's not being stretched, it's being scrunched, okay? So we do the exact same thing. You do the final position of the spring minus the initial position of the spring. But in this case, we're going to start off with our little number up front. So it's going to be 0.2 minus 0.25. And that's going to equal negative 0.05. So make sure you keep those negatives in there. And then that's going to be plugged into our spring force formula. So that's going to be, what is our spring constant in number 2? 75. So it's going to be negative 75, just plug it into your formula, times negative 0.05. So watch those negatives. And you're going to equal 3.75 newtons. Because when you have two negatives multiplied together, you're going to get a positive. Okay? All right, let's move on to number 3. Number 3 is exactly the same. You have the same information, but we're looking for something different. Instead of looking for the spring force, we are trying to figure out the elastic potential energy. In order to figure out the elastic potential energy, you need the correct formula. The correct formula for elastic potential energy is 1/2 times your spring constant times the position squared. Okay? So that is your potential energy formula. You got to know that. Okay? So let's go ahead and do this problem. So all we have to do is just plug it in. So 1/2, we know that. What is our spring constant in number 3? Our spring constant is going to be 300. And what is our displacement? What is our position? Our change in position? It's going to be our final spring position minus our initial spring position. So that's going to be 0.5 minus 0.4. So we have 0.1. I think my dog is eating a creature out there. Squared times 1/2. Okay? Here it is written out. So the answer to that would be, when you plug that into your calculator, our potential energy is going to be 0.15 newtons. Got it? All right, last but certainly not least, we're going to do the exact same formula. We're looking for potential energy for number 4. What's our spring constant in number 4? Our spring constant is going to be 50. Times, what is our change of position or displacement? So we go from a spring that's 0.3 to the compression of the spring where it ends up in the position of 0.2. So it's going to be 0.3 minus 0.2. So we have 0.1 squared. And when we put that in our calculators, we get 0.25 newtons. All right? All right, if you have any questions whatsoever, please let me know. I am happy to help. Today would be the day if you have an immediate question. You can text me, 843-834-3333, and I will be sure to respond to you as soon as possible. Okay, guys? Y'all are awesome. Be sure you're studying well for your test, and we will see you later. Bye-bye.